Assalamualaikum warahmatullahi wabarakatuh, and very good morning to all of you. Today I will present on the research topic of development of artificial neural network, optical properties, ANN based Tualahani identification system. This is my Doctor of Philosophy project in electrical engineering. My name is Muhammad Hazlan bin Zakaria, and my supervisor is Prof. T.S. Dr. Muhammad Mahdi bin Abdul Jamil. Working together as my co-supervisor is Dr. Wan Suhaimizan bin Wan Zaki and Dr. Arifuddin bin Joret. So today is the outline of my presentation. First is introduction, second objective, third problem of statement, fourth methodology, fifth preparation of honey samples, sixth result analysis and discussion, seven neural network on simulation, analysis result using MATLAB Simulink, eight conclusion, nine significance of this study, 10 is references. As an introduction, today 90% of the selling honey in the Malaysian market right now is not original of honey, and they are all adulterated and added with sugar or water. This article is coming from Berita Harian and News Straits Times on the Malaysian market news. So as to ensure the authenticity and maintain high quality standard, it is essential to develop an efficient identification system. This project research aims to leverage optical sensing and artificial neural network ANN for accurate identification of tuala honey, providing a non-invasive and reliable method. So, on the objective of this research, first, analysis of optical properties to analyze the light absorption and transmission characteristic of tuala honey using an optical sensor system. Second, ANN artificial neural network model development to develop an artificial neural network ANN using AI model for identifying tuala honey based on its optical properties. Third is system implementation to design and implement a tuala honey identification system using the ANN model integrated with the optical sensors. So for the problem statement, first, to design portable optical detection system by application of fiber optics that can differentiate between honey quality according to their pureness. Previous method of adulterating pure honey with glucose substance and adding sugar has some weaknesses and pretty hard to predict and identify the originality of pure honey. Third, due to high commercial profit, many fraudulent have been around to add other substances to pure honey. And fourth, time consumption needed to obtain result of purity honey based on sample from lab basis testing. So for the methodology chapter, there are four processes from the data collection, data analysis, ANN model development and system development. For data collection, obtain sample of authentic tuala honey and other type of honey for comparative analysis. Utilize an optical sensors to measure absorbance and transmitter across various wavelengths. For the data analysis, pre-process the optical data to extract meaningful features, example spectral pattern, analyze the relationship between optical properties and honey classification. And for ANN model development, train the ANN using the pre-processed data to classify honey samples optimize the network architecture and hyperparameter for maximum accuracy. And lastly, for system development, integrate the optical sensor and train ANN model into a user-friendly identification system. Validate the system performance with unseen honey samples. So for the preparation of honey sample, first, before fill up sample on quartz cuvette with liquids and honey, all 5 sample honey had been filled on quartz cuvette, and test the honey sample using UV spectroscopy device, which is used for test to run absorbance transmittance test. So first one is the absorbance signal response between pure tuala honey and non-pure tuala honey. As we can see from the 3 time of measurement, the data look consistent and the pattern of graph also consistent. And we can see that the response of pure honey slightly higher compared to the pure honey. The pure honey is higher response compared to the not pure honey. On the next graph is transmitted signal response between pure tuala honey, PTH, and non-pure tuala honey, NPTH. As we can see from all the 3 time of measurement, the data look consistent and the graph pattern also consistent, and the response is not pure honey is higher response compared to the pure honey. For the third graph, absorbance test signal for 5 different samples of liquid compared with pure tuala honey, where we use tuala honey, syrup, apples, cider, gold, honey, and also water as a base of references. And this graph is the transmitted test signal for 5 different samples of liquid compared to pure tuala honey. As we can see that the response for the apple cider is higher compared to the rest of liquid, including tuala honey, syrup, and water as a references. And fifth, calibration system using glucose syrup for absorbance test. In this test, we diluted honey with 10% of glucose syrup as a step size to 20%, 30%, 40%, 50% up to 100%, where it becomes the total glucose syrup. And we can see that the absorbance test graph pattern is look like this. And we compare with the next one, calibration system using glucose syrup for transmitted test. And this also same process as the previously mentioned. And we can see that the higher response is on the 20% diluted honey with the glucose syrup. And the next graph is the permittivity of set honey. We can see that these cold parameters for the pure tuala under test, and the comparison of the permittivity result obtained by the transmission line technique T series and the dielectric probe technique is D series. So the permittivity of set honey continue in this graph. We can see that the black dot is the no added glucose, red dot is 10% of added glucose, and blue dot is 20% of added glucose up to 50% of added glucose. And for the imaginary section of graph, we can see that for the no added glucose is lower compared to the 10%, 20%, 30% added glucose up to 50%, which is higher compared to the no added glucose. As we can see, the effect of added glucose syrup contained on the permittivity of adulterated pure tuala honey. And effect of added glucose syrup on permittivity of adulterated pure toilet honey. The permittivity result obtained can be fitted by regression to the equation of the equation 2 and equation 3, where the mu is the weight percentage of added water in the honey glucose syrup mix. And then we can see that with the added glucose syrup content on the permittivity of adulterated pure toilet honey. And this is the graphical benchmark between real and imaginary of clear honey, and also real and imaginary of set honey. So the calibration curve showing relationship of mu R and mu R real and imaginary with added glucose syrup content at 7 GHz for clear and set honey. So for the next process, we will see that the neural network on simulation analysis using MATLAB. As we can see that the result using neural network MATLAB for data A, the training is 34, validation and test is 7. And for the error is 0.0882 for training, and validation is 0.1429, and test is 0.2857, where the error rate is lower, approximately at 0. For the next one is neural network MATLAB for data B, where the training is same 34 and validation and test 7 as the previously mentioned. For the error rate is 0, which is very accurately, and no error produced. For the next data set is the neural network MATLAB for data C, where the training is 76 and validation and test is 17. And we can see the error percentage of training is 0.0132, is lower compared to validation and test error rate, which is 0.2941. And for the data set of B, the training is 76 and validation and test 17. And we can see the error rate for training is 0.5, which is lower compared to validation and test error rate, which is 0.6471. And the next one is the data set for the data E. So the training is 34, validation and test is 8, the error is 0, which is approximately accurate to no error. For the data F, we can see the training 34 and validation and test is 8 as well. The error for training, validation and test is 0, which is very accurate to the system classification. So for the data A version 1, when using the neural network design, we can get the 5 plotted of graph for performance, training state, error histogram, confusion and receiver operating characteristic. Where for the performance plot perform, best validation performance is 0.10248 at epoch 13. Where we can see that the training is the blue line response, compared to the green is validation response, and test is red line. As we can see that the validation system is higher compared to the training and test. So for the error histogram plot histories, the error histogram with 20 bins, so we can get 0 error, which is accurate to the system classification of reducing error. And this one is the confusion metric graph over the output class. Okay, for the next slide is a data A version 2 set. So we can see that pattern recognition neural network, as per display in this image, we can plot the 5 training plot graph as a previous mentioned, which is performance, training state, error histogram, confusion, and receiver operating characteristic. So for the plot performance, we can see that the best validation performance is 3.103 exponential minus 0.7 epoch 38. We can see that all of training, validation, and test is approximately close between each other, which is very accurate to the system classification. And the next one is the confusion, plot confusion graph, where the plot graph is between the confusion metric over output class. So as the conclusion of this presentation, we can see a comprehensive understanding of the optical properties of tuala honey. Second, a robust ANN, artificial neural network using AI model, capable of accurately identifying tuala honey. And third, a fully developed identification system that ensures authenticity and prevent adulteration. And the next one, the significance of this study. This project will provide a novel, non-invasive approach to honey identification classification system, promoting transparency and trust in the honey market. Furthermore, it will demonstrate the potential of integrating optical sensor and ANN in food authentication application. And the next one is the list of references, which is the major reference used for this research to compare from the previous method up to now, and coming with this new research to fulfill the gap between the research previously. Okay, and then thank you for your attention, and we can have a Q&A session. And from me, thanks very much, and see you soon, and we will meet again. Assalamualaikum warahmatullahi wabarakatuh.